Next question, what is a decorator? In Python, functions are first class objects. That means a function can be passed into another function as an argument and a function can return another function as output. A decorator is built entirely on this idea. A decorator is a function that takes another function as input and wraps it with additional behavior and returns the wrapped version. When you apply a decorator to a function, you are essentially replacing that function with a new version that does something extra before the original runs, after it runs, or both. The et symbol in Python is just shorthand. When you write et timer above a function definition, Python is doing exactly one thing behind the scenes. It is passing your function into the timer decorator and replacing your function with whatever the decorator returns. That is all. There is no magic in it. Now, why are the decorators useful? In any real application, you have what are called cross-cutting concerns, behavior that needs to happen across many different functions, but has nothing to do with the actual business of those functions. Things like logging, authentication checks, performance timing, caching, and retry logic. Without decorators, you have two bad options. Either you copy and paste that logic into every single function, which violates the principle of not repeating yourself, or you manually wrap every function at the point where you call it, which makes the code harder to read and maintain. Decorators solve this cleanly. You define the cross-cutting behavior once and then apply it to any function with a single line. The function itself stays focused purely on its own logic. Now the application in practice, logging, you wrap a function so that every time it is called, the call is recorded automatically without touching the function itself. Authentication in a web API, you wrap an endpoint function so that it checks whether the user is authenticated before allowing the function to execute. If not authenticated, it rejects the request immediately with a 403 error. 403 error is upon authorization when the user is authenticated but not authorized to do so. Then 401 error is the authentication error when the user cannot be authenticated. Caching, you wrap a function so that the first time it is called with a given input, the result is stored. Every subsequent call with the same input returns the stored result instantly without recomputing. This is extremely useful for expensive operations like recursive algorithms or database queries. Retry logic. You wrap a function that calls an external service so that if it fails due to a network issue, it automatically retries a set number of times before giving up. So ultimately, the applications that I have told you are logging, authentication, caching, and retry logic. Can you do without decorators? Yes, completely. Decorators add zero new capability to the Python language. Everything a decorator does can be written manually. The reason decorators exist is purely about code organization, readability, and the DRY principle. They let you express intent clearly. When a developer sees it require underscore auth above a function, they immediately understand that function is protected without reading its implementation. In Java, the closest equivalent is annotations, things like at the rate, override, at depreciated, or in the Spring Net framework, at rest controller and at get mapping. The difference is that Java annotations are metadata processed by the compiler or framework at startup, whereas Python decorators are actual functions that execute at runtime the moment the function is defined. The closing one-liner, I would say that a decorator is a clean, reusable way to add behavior around a function without modifying its code and without repeating yourself across the code base.